Okay. Good morning, good afternoon, good evening. Thank you and welcome to our Lucid Technology and Manufacturing Day. We have an exciting day for you today, and I'd like to thank you for everyone who actually made this trip out to Casa Grande, Arizona. For all of those who are joining on the webcast globally around the world, thank you for joining us. Before we get started, I do want to please ask that you review some important information on this slide. And without further ado, let's kick it off.
It's peak EV right now. This is as good as it gets. This is one of the best sedans ever made. I'm not saying electric, it's one of the best sedans ever made.
Dare I say it's one of the best driving cars I've ever had the pleasure of driving.
Please welcome Lucid Group's CEO and CTO, Peter Rawlinson.
Thank you, Maynard, and thank you so much. A huge welcome to everyone who's joining us here in the room, to investors, analysts, and dear customers of Lucid Airs. And really to all those who are joining us online, right across, good morning, America, good afternoon, Europe, and to our dear friends in the Middle East, good evening to you all. Thanks for joining us today. We're going to have a real blast. We're going to have a fun day. You're going to see what I think is the best, most advanced electric vehicle plant in the world today. This was the first dedicated EV plant in North America. And then we're going to have some rides in Gravities, and we're going to have a Sapphire experience. And since I plan to drive you on that, I do caution you to be careful and go easy with your breakfast this morning. But I want to, just before we start today's proceedings, I just want to take a little bit a step back in time. How did we get here? What brought us to this stage of our journey? Well, really, Lucid really started in around 2016, when I led a small group which founded the company. And if it wasn't daunting enough to embark on a journey where we're going to create a car company from scratch, our goals were actually higher than that. We needed to put the best car in the world into production, all electric, of course. And why do we need to do that? We need to really push the envelope of what was possible. And really, this is really central theme to today and our business. It's advancing the state of the art of EV technologies, because we're still not there. I think we've overcome range anxiety. We've got a car with over 500 miles range. But at what price? We need to drive down costs. And it's not just scale, it's technology as a solution for those costs, which is going to bring broader electromobility to benefit all mankind. That's why we're here. That's why I'm here. That's why we created this company. So, to that aim, in late 2016, I had the pleasure of unveiling a first prototype of the Lucid Air. And that was well received. And then all we needed was a little matter of some funding to put it into production. So we had to roll two barren years on to 2018. And what do you do when you need money in the automotive business? Well, like Ferrari before us, you go racing, right? That made perfect sense. So what we did was we created the battery pack that powered the EV Motorsport World Championship. And the reason we did that was not so crazy. There's a whole bunch of startups with EVs looking promising. I knew we had something tangible, something hugely differentiated. We had real world core technology. I didn't have the funds to put Air into production. We could do this and get a little revenue. And really, this litmus of 4 successful seasons powering all the cars in the World Championship for electric single-seater racing, hugely successful, and really was a key catalyst in the thinking of joining our dear partners, the Public Investment Fund of Saudi Arabia, who invested in us, had the foresight, had the vision, could recognize what differentiated us and our technology. And through then early 2019, the funds were secured, and here I am with Governor Ducey of Arizona, planting the tree at this very location. I'm not quite sure where this tree is. It's somewhere out there. And someone will have to point it out to me. But yes, just a little bit of steel work in the background. The very first purpose-built plant in North America was being erected before our very eyes. And then, this was December 19. And then we all know what happened early 20. And against the backdrop of COVID, in record time, we built out the first phase of this plant. And by August of 2020, we're actually building prototypes, beta prototypes of Lucid Air, the most advanced car in the world, in this facility. We grew a fleet of Airs, we tested them extensively, and then it culminated precisely 1,462 days ago. That was September the 9th, 2020, when I had the honor of presenting, and it was not a live event, it was during the height of COVID, so we were distanced, and I announced and I promised the world's first 500-mile range electric car, and some people believe me, I think it's fair to say, but there was certainly skepticism. Roll on to 2021, and we went public on NASDAQ, and later that year we actually started production and delivered Lucid Air with up to 520 miles range in the Dream Edition range version. And we had that validated independently by a very respected journalist, Tom Maloney, who actually achieved exactly 500 miles range at a steady 70 miles an hour. This was real. This was real world range. So then, rewind on 2022. I had the pleasure of unveiling Sapphire, which is going to be the highest performance true production car in the world, the ultimate for driving response and performance. And also in 22, enter the Bear. We really adopted the proud beast from the flag of California as our brand mascot, as our emblem, as our logo. And you see the Bear in many locations right throughout both Lucid Air, and again that continues with the Gravity. Roll on to last year, we were delighted to announce a powertrain supply contract with Aston Martin, and that was to supply, amongst other things, this unbelievable rear drive unit from Sapphire. Sapphire was the key enabler. Sapphire's got 1,234 horsepower. Perplexingly, that unit is capable of more, 1,341 horsepower, which is a megawatt. So it's actually, Sapphire's limited by battery power. We'll be able to unleash more power when we have more battery performance available. We also were delighted to create the very first car plant, to the best of my knowledge, in Saudi Arabia, which is running hopefully today. And this is a kit sub-assembly type of plant where we're producing Lucid Airs in all versions for the kingdom. Then we announced the pure rear-wheel drive start of production. This is the most efficient, most environmentally sustainable car in the world, and Sapphire actually went into production. Now, many of you may share a passion with me. I'm a big fan of motorsport, and I was avidly watching the Formula One, the Grand Prix at Monza. Allow me this little distraction, but I wanted to show this for a bit of fun. And we saw Piastri and Norris duking it out with McLaren front row, George Russell coming a bit too close, and we see these are the distance versus time traces of those leading cars. In green, you see a Lucid Air Grand Touring. But if we overlay the Sapphire, which is in blue, you can see that we have a car, which is a four-door, I hesitate to say family car, but it's a four-door, five-seater car, which has got incredible practicality, and it can actually run neck and neck with the very front of the Formula One grid. That's how far the technology's come. And let me tell you how we've done this. And this is an important point that I'll come back to. The software, the in-house software, which is world-class of Lucid, has enabled that. This isn't just power. This is about laying the power down with traction control. Our traction control algorithms are all created in-house. That's what enables the tractability, and the power is nothing without control. And we have got truly world-class software, and that's not truly recognized. And I'm going to come back to that. So after that, we launched Gravity complete with frunk at the LA Auto Show. And really, you know, it's going to propel us to the volume that we need. So it brings us on to this year, huge investments, right across the piece, really. We're putting the groundworks, completing into our big factory in Saudi Arabia. This will be good for 150,000 units per annum, and we've got to sync that in readiness for late 26, ready for start of production of the mid-size platform. Now, what do we have today? We have the longest range, real-world range of electric cars that are out there. We dominate the front running. And in fact, at this moment, not only today do we have 100 miles more range than the closest competitor in that marketplace, but we actually have 100 more miles range for a car that we started producing 3 years ago. No one is within 100 miles of the car that we brought out in 2021. And that was, again, independently validated by Carl Connor, who achieved over 510 miles in real world at 70 miles an hour very recently. So to wrap up, we have the longest range cars, but there's something much more important than that. It's how we achieve it. We achieve the range with less. That is more important and more significant long-term for this planet than range per se in absolute terms. And that comes to efficiency, how we represent that. Efficiency is how far can I go with how little. And we've got a landmark, Pure here, which has achieved 5.0 miles per kilowatt hour. Yeah, that is a real landmark, because that means this car will use literally less electricity to go from A to B, whatever your journey, than any other car. In miles per gallon equivalent, that's 146, which is a record out there. This is an extraordinary achievement, but we're not resting. I've announced our Vision 6 program, and many of my engineers and scientists are working assiduously. How could we get to the magic, the holy grail, 6 miles of range per kilowatt hour? Effectively, it's a 10 kilometer per kilowatt hour, and that's what I've said will anecdotally save the planet. This is what's very important for us, and it's central to Lucid's existence and mission. And why is that important? Because if you look at this, you start seeing, this is for US over the last number of years, you see the white line, transportation. The dip there is from COVID, actually, which is interesting. But transportation has a huge impact upon greenhouse gas emissions right to this day. This is why this is critically important for us. So, I'll wrap up very soon. We're sitting on an unprecedented range of awards and accolades for Lucid Air. I think it's the most awarded new car from a new company in history. We've got incredible advocacy and recognition right across the spectrum here. And I would say, just to wrap up before we get into today's presentation proper, there are two key differentiators to us. On the one hand, we've got the great support of the Public Investment Fund of Saudi Arabia, who have been rock-solid partners throughout this. I can't speak too highly of them. And on the other hand, I believe we have the best technology in the world. And you put that together, we have an alignment of stars, which transcends a mere financial arrangement. This is, we're mutually incentivized together for this Saudi Vision 2030, a bold vision where the kingdom's preparing its people for tomorrow's world, and we say yes to that. So, really brings us back with a bump to today. Here we are, and I just want to, before I get into the proceedings, I want to just give you 3 key messages. And if you remember nothing, if you go away shaken, not stirred, with your ride in the Sapphire later on, see the factory, see more robots than you know how to wrestle with, I want to give you 3 key messages, 3 key takeaways. If you remember nothing else, these are the important things, okay? Lucid Gravity is going to be the best SUV ever. I'm going to go one back because that's the first point. I bungled the click. Best SUV ever. How and why? Because it's got revolutionary packaging. How can we do that? It's only possible via our technology. We spent so many years investing in this tech. We've got the most miniaturized drive units. You can see this one here, just how small this is, up to 670 horsepower. No one else is not even close. And because it's so efficient, we can do it with less batteries than anyone else. And so we've got the best tech. No one else can do an SUV like this, not even close. But there is kind of an elephant in the room, and I want to address this today, because there is a misunderstanding. Some people think, oh, well, you've got the best tech because you're throwing so much money at your tech, it's unaffordable to make. I'm going to show you with independent, third-party validated data, not a claim from me, that tech is inherently cost-effective to manufacture, and not just that, but actually it's a cost-down driver. So, without further ado, let's go into the tech. What constitutes our tech? Right. So, we've got the motor and transmission, which is part of this drive unit. And on top we have the inverter, that's the black box that really controls our motor system, and that's where the brains are. We have the Wunderbox. It's D Wunderbox, I'm told. That is the correct designation of its gender. And here we have a module from our battery pack, which is a modular design layout. And holding that together, of essential significance is our world-class software. We would not get the best range of any car in the world today, the highest performance, the highest efficiency, without world-class software. And I'm going to cover that because I think there's a misunderstanding about that. So, how do we do this? Well, number one, we start with first principles. Now, look at those power lines that transmit electricity across America. Look how crazy high the voltage is. There's a reason for that. If you want to reduce electrical losses and you want to transmit tons of electricity, you go to hundreds of thousands of volts. Well, we're not going that far with an electric car. That would have many challenges. But we've gone to the highest voltage I'm aware of in production. And there is a cogent scientific rationale for that. When others are at 400 volts, it's not because they want to be at 400 volts. They should be at this. This system isn't at 2,000 volts. It's over 200,000 volts. So this is laws of physics. There's your example, and this is what we're doing. And that's a starting point. We've also got the fastest charging EV in the market, and it reduces energy losses. And central to that is our drive unit here. And this is in mass production here in this factory. We've been making it here in Arizona for the last 3 or more years, and we've recently integrated it into this building. We've moved it from our satellite factory just up the road, and we've put a lot of automation into this. And you're actually going to see our visitors today. Sorry, online, you won't be able to see this, but this is the crown jewel, and you can actually tour the facility that makes that in mass production today. I believe it is not just the most advanced in the world today, it is by some margin. And let me just go through some of the features here. We've got next level electromagnetics, and we've got next level thermal control. And one of the ways we achieve that is we put these little microjets slots in the stator, in the core of the stator. The enemy of efficiency is heat. If you can nip out heat, that's the key to getting efficiency. It's thermodynamics as much as electromagnetics. So how do we do that? We have this microjet cooling system, and this is unique and heavily patented. That keeps the copper cool rather than saturates the whole thing with heat. Then we have a very innovative way of winding our motors, and this is, we actually have a weaving loom, and we actually weave copper, and it looks like this, and we actually make a real long strip of this, and then we roll it up and insert it in our motors. This looks rather rough and ready like this, but this is all computer-controlled, robotically assembled, and we will actually show you the inner sanctum, the crown jewel of our manufacturing capability, how this is made. And if we move the camera up here, we can just compare if we can bring the camera right forward, please, in here, we see what our technology looks like. This is when this is inserted. It's truly repeatable, highly controlled, and a beautiful, beautiful thing, very cost-effective to make. And if we look at the other approaches to making a stator winding, here we have a competitor with a thin strand, random wired arrangement, which is literally held together with pieces of string. And here we have this hairpin design, where we have to have many, many welds because the hairpins are inserted through. And this is a rather traditional way of approaching this. And no one else does this continuous wave winding to the best of our knowledge. This is something we have pioneered. And it's absolutely central because you have continuous flow of the electrons without any interruption, and therefore there's less cost, there's less welds, there's less connections, and there's less wasted energy. Now, I want to go on to a central part of the motor, which is the rotor. This is the bit that spins. And, we have a really, really important double-layered V-magnet arrangement here, which is patented. And we have a hollowed-out center in which we insert the differential, which is quite unique. And it is really key to our compactness. But the electromagnetic research that went into this positioning of these magnets is absolutely central to our incredible performance. And I'll go into that in a little bit more detail in another part of the presentation. Then we have the inverter. This is a silicon carbide MOSFET. It's a silicon carbide chip, and it lives arrangement with multiple chips, in fact, on many modules deep inside this unit. It's got the most advanced parallel cooling technology. If you look at thermal cutout events and EVs, it's just really, you can chase the weakest link in the chain. And if you put parallel cooling in, which some people do, it's the last MOSFET that's got the warmest water, the least cooling, will induce the cutout. So we equally cool in parallel all our modules with these chips inside. And we've created a turbulence to get a non-laminar boundary layer, which improves the conductivity of the fluid in that area. This is absolutely critical. You can see some of the elements, all the printed circuit boards designed in-house. This is the most advanced inverter in the world by some margin. And then we have the Wunderbox, which is our integrated charging system here. This is a multifunctional box. Other people don't have this because it combines charger, boost charging. It's a high voltage distribution system. It's even got a 400 volt spur for AC compressor. It's an incredible example of integrated capability, which is super cost effective, put it in one unit, and it also acts as a secondary bulkhead structurally to enhance crash performance in the vehicle. Unbelievable. It's actually a secondary bulkhead. It acts structurally in a crash. And then we have our battery module, which is truly race-derived. We've created an award-winning design here. The actual connectors are all integrally molded into this injection molded. These are not extra parts that we have to fit on. The molding oozes around that, and it comes out as a one-shot deal. And this has a structural contribution to the vehicle. It truly is a motorsport derived, as is our battery pack. This is where we started with the World Championship for electric vehicles, all that knowledge embedded. Now, I want to start going on to other techie things. I want to look at a whole zonal architecture. While others are now embracing a zonal architecture, we actually led. Back right in 2021, with the very first cars that we ever made, we introduced an Ethernet ring, 4 nodes, a data superhighway. And every Lucid Air that has been made features this. And others are now catching up. There's competitors now, the last 8 months or so, touting, hey, we've got an Ethernet ring. Well, yeah, 2.5 years after we pioneered this. And, it really is a software-enabled car. That's what we've got here. And this is why we've been able to put about 80 or so, I think it's that number, JP, of software updates. And we put a big one out yesterday, and that was no coincidence. I wanted to show that we really are a software-enabled car from a tech company, and we're really taking this very seriously. The car gets better with age. We're able to put that out right across the fleet. And this zonal architecture is in every Lucid produced, and it affects deep inside the car. Just as every EV is not equal, not all OTA, over-the-air capabilities of vehicles are not equal. We have this deep enablement through OTA, and it affects so many of the ECUs deep inside the vehicle. We have this ability to change so much of the functionality, much more than many competitors. So, collectively, this has a huge impact upon how far we can go with how little electricity. And this is absolutely central. If you look at the runners and riders in the marketplace today, and I've shown this slide before at earnings, we actually are right up there at the very peak of efficiency at the magic 5 miles per kilowatt hour. And this is a cost-down enabler as well as having profound ramifications for the environment. If you look at the chart, we also see the implication of cost. And that is the cost per mile of endowing an EV, any EV, with any amount of range. That is the cost of the battery. That's how much it costs per mile. So, if it's 100 miles range and it costs $58 per mile, that's a $5,800 cost for battery. This has a profound cost-down impact. It also has a profound impact upon the grid and the draw upon the grid. A sensitive grid, and it also has a profound impact upon one's wallet, because although electricity is relatively affordable overnight, off-peak, I know that when I've been fast charging, I'm quite shocked. It's about 55 cents a kilowatt hour. It's quite expensive, actually, fast charging, and that's another reason why it's better to have a longer range car in many ways than rely upon fast charging. It's much less hassle, it's better for your battery, and it's actually better for your wallet significantly. And this is really significant. So this led to me somewhat controversially posting this trajectory line showing where we are. And these are, this just shows the simple facts. This is from EPA efficiency, and we've done it as MPGE rather than miles per kilowatt hour, because you can't definitively, you can believe MPGE because it's from a trusted source. If we actually rely on individual manufacturers' kilowatt-hour claims of pack sizes, then that becomes a bit more tenuous. So we've used this as a reference datum. You can see the trajectory that we're taking, and the others have still quite a challenge to catch up. And I do want to say this: don't believe if anyone says that this doesn't matter, and they're not trying to do that. That is not true. I know the engineering world is a very small community. They're trying like crazy, like absolutely crazy. And one of the German manufacturers recently announced they'd made a series of breakthroughs, and they just got over 3 miles per kilowatt hour. Depending upon what data you take for the market leader, they may be just over 4 miles per kilowatt hour. This is a very significant lead, and this really is the metric for our prowess and provenance as a true technology company. Okay? Now, I just want to go on. We've also happened to be the fastest charging car in the world. And why is that? Is it just happenstance? No. Let me tell you why. Because that is, and it is so misunderstood. One of the reasons we charge so fast is because we've got such amazing efficiency. So let me take you through that. Efficiency makes your car charge faster. Not in terms of percentage of SOC, which doesn't really matter. I'm not really interested in 10% SOC to 80%, that's irrelevant. That's a measure of how many electrons have gone in and how big the pack is. I'm not measuring how many kilowatts are being drawn from the machine. All I want when I stop for a coffee is to know how many miles per minute have gone in the vehicle. That's all that matters. So it's the rate of charge I view is miles per minute. Those are the units. And, really, there's this kind of misunderstanding. It's seen to be directly equivalent to power in kilowatts. That's the amount of electrical power. That's the flow of rate of electrons that are going in. And actually, that's not quite the right formula. You have to multiply the power in kilowatts by efficiency. And this equation does stack up, and you have to divide by 60 because it's kilowatt hours, and I'm saying miles per minute, which is more understandable. I could go miles per hour on the left-hand side, and I could get rid of the 60. But this is, the rate of charge is directly proportional to efficiency. I haven't put equals because there are some charging losses, and I want to be absolutely accurate and precise here. But bear that in mind. It is no coincidence we've got the fastest charging car because we've got the most efficient. Everything gets better. So let's have a look at that in real world. There's a lot of chatter, a lot of interest in the EV sphere, that there's a well-esteemed German electric sports car, which has just come out, which has got an awesome charging curve. And it truly has, in terms of its ability, in terms of its SOC. And that's shown here on the purple line. But it's still not close to a Lucid Air because we've got the efficiency advantage. This is measured in miles per minute. So this is apples for apples. This is the best of the competition. So let's have a look at the rest of the competition. You see the runners and riders, the market leader, and two very prominent German brands. And get this, everybody, they all seem to run out at this point here because that's how much range they've got. They can't go to 500, can they? They're trying. Right. So I want to go into now I want to go next into this big elephant that's in the room. There's this misunderstanding, and I've heard it so many times. Oh, Peter, you're an engineering nerd, and you're driving the cost. You're not a business guy. You're putting all these crazy expensive materials into your technology. That's how you've got the edge. Anyone else did it, they'd have even better technology. So how do we do this? How do I give you some evidence that what we've got is legit and it's actually cost effective? So we had a turn. You can't have me making claims because it's Peter will claim this and Peter's going to claim that. It's all about having an independent, trusted source. So we've drawn upon A2 Mach 1, which is a German, it's the gold standard for automotive, cost, teardown. These people are really professional, they're internationally recognized, and so we've commissioned some data from them. And so I'll be quoting that, but if I draw a conclusion from that, I will state that, to be fair. So A2 Mach 1, this is their synopsis. This is a spider chart, and you should have all this information available. And we're going to put all this up on our website, so don't think you have to digest this, blink and you miss it, because you'll be able to look at it. So this is a spider chart with 5 key criteria, such as horsepower, torque, cost effectiveness, weight, you name it. And you see that actually, I mean, this is their data, this is not mine. I was shocked. I don't think I would put it as far out as that, but it just shows just how differentiated we truly are. So let's look at those drive units in a little bit more detail. So we've got 4 drive units. One is this one, the Lucid one, which is in mass production today, and then we've got 3 key competitors, American leader and 2 esteemed, storied German brands. And then we're looking at absolute horsepower. And this is from the data that was provided by A2 Mach 1. Some of these, to be fair, they might have a derivative more recently, which is higher power. So I just want to be absolutely fair and equivocal here. So let's have a look at the mass then. How does the mass stack up? Well, yeah, it's not looking great. So let's say what is the horsepower per kilogram then? Yeah, I think that's telling a pretty clean story. I think that the other runners and riders, this is pushing towards 9 horsepower per kilogram. And that's not the motor, that's the drive unit. If we're getting 9 horsepower per kilogram at drive unit level, probably the motor's more like 20 horsepower per kilogram. And I've seen that misquoted as well. So what does this mean? We've got a cost breakdown of these drive units. These are a central, huge part of the cost breakdown of our technology. And this is from A2 Mach 1. And this is how they cost things, okay? So, well, we're not the best. Competitor A, the market leader, is the most no, I wouldn't say cost effective, it's the lowest cost when we look at it this perspective. And we're competitive with the Germans, okay? And this is for a normalized, I should say, production run at a set location in the world. This is all normalized because clearly our numbers are higher than this now because we're scheduled to make 9,000 cars this year. So we need scale. So this is normalized in a steady state situation, okay? Now, however, you really have to make an allowance for the weight reduction here that we've got. We've got a 20 kilo weight advantage, precisely 76 versus 96. And I mean, this is up for debate, but I personally would attribute about $6 per kilo for weight savings for a system in a car. And that's widely recognized. Now, that's not an A2 Mach 1. I want to disclose that's a Peter figure. But if we make that allowance, then we've got to say, look, we have 20 kilogram weight saving, that's worth $120. So really got to take that normalized for mass off. And then we're right there, very close. Right there, better than the Germans, approaching the level of the market leader. But there's something else. We've got twice the power. This is twice the horsepower. So what if we normalized for power? We'd be almost half the price. Now, I don't want to do that because I want to be absolutely fair. Because if the competition threw some more silicon carbide at things, that would increase their price a bit. They might be able to upgrade that performance. But you've got to say that that delta, it is almost precisely twice the power for just what? $140 more. I mean, as a value proposition, that is just different league. And that's compared with the market leader. And those are figures that, as I say, are provided by A2 Mach 1. Now, so what are we going to do about this? Well, I would like to announce our lower performance 335 horsepower drive unit, but since it's top secret, this is the best I've got. So sorry for the tease, but I did show you the Bear, and I did show you the Zeus drive unit. This is our Atlas drive unit, and I had a picture yesterday from our art studio, and it was showing too much, so I said, let's make it black because people would like to see this. And this is our next generation drive unit. It's going to embody all our learning. This is going to be like our 335 horsepower version, and that's going to be so much more cost effective. We've learned so damn much. It's insane. And so where's that going to go? Right. So it's going to go into mid-size, late 26. And you've seen a picture of mid-size. There might be more to come. Watch this space. But here's the cost consciousness in me. I think we can explore, when that gets ready, cost down in Gravity, more affordability. This is important. And even, potentially, in Lucid Air. So I think it's time to go into a little bit more detail. Allow me to go in a little bit more detail on where these figures have come and how can this possibly be achieved at all. So let's have a look at just the cost and mass of some of the components. And I'm a simple guy, and I'm a mechanical engineer doing electrics. The motor to me has got two parts. There's a stator, which doesn't move, and there's a rotor that spins. So if you looked at this, the electrical steel and the copper in the stator, really it's very much a function of how big the thing is. And if we just move the camera here, you can see our unit, just how compact it is. And it's about twice the power of these German competitors. And these have got a lot more copper and a lot more electrical steel in. So it's very much a function of how much mass of materials you're putting in. And what's the average of those? And we're still looking pretty good. And let's look at in percentage as well. And, you know, in terms of copper cost, we're about 50% of the average cost. This is our tech. This is why our tech is affordable. People don't realize it. And look at the steel. We're right down there. We're super competitive. And we can do the same for the rotor. And you can have all this data. It'll all be online. And we can do the same analysis. And we can show just how competitive this is. But I want to go a little step further here. And first of all, I'm going to take my watch off, my Swiss watch, because I'm going to go near something with extreme electromagnetism. And I do want it to work again. Thank you. I'm going to look at a couple of rotors here. Can the camera go right in, please? This is our rotor, a Lucid Air rotor. It's a very simple device. It's a steel-bound device. Very simple. And that is remarkable because unlike a fighter pilot who can survive 10G, I think that's what they experienced in Top Gun. A good, fit, young fighter pilot can experience 10G. The magnets in our rotor experience, wait for it, there's our rotor, there's the magnets. They experience 30,000 G at 20,000 RPM. This is the fastest motor that I know of in production. That creates huge forces. Those magnets become weighing tons. And you have to hold them in and literally stop the motor exploding. This is central to performance. This is how Sapphire achieves a quarter-mile run at 8.9 seconds. It's not, everyone's obsessed with low-speed torque with the motor. I did a tech talk with Imad Dalala, Dr. Dalala there. We did a tech talk showing it's the bandwidth of performance which is critical, not just the low-speed torque. And so what we've done, and we're very delighted to have done, is we've actually got enough steel around the edge of those magnets to hold them in from these massive 30,000 G forces. It's quite extraordinary. So that's prompted the competition to try to compete. So what does the competition do? So please come on in. We have an example of a competitor rotor here, which also spins at that speed. And this is still excuse me, it's so heavy. This is highly magnetized. And what they've done is they've wrapped the rotor literally with carbon fiber to stop the thing exploding. And why has that been necessary? Because the electric magnetic regime isn't as advanced as ours. They've had to put the magnets right on the outside to achieve the torque. And they literally had to resort to wrapping it with carbon fiber. And we haven't got any of that expense. And even, you know, when I'll show you our most advanced motor in the world, which is our motorsport motor, we don't do that then. So I put it to you that it isn't that Lucid is using crazy expensive materials and processes to get our advantage. I put it to you that actually the converse is true, that it's the competition going to extraordinary lengths of adding complex and very expensive processes, just trying to keep up. And remember, this is the carbon-wrapped version is literally half the power output of our non-carbon wrapped affordable version. That is the level of difference. So if anybody wants to sort of mislead you and make a claim that this is, alien technology of some sort, I would refute that. To me, this is a Band-Aid, and a damn expensive Band-Aid at that. So I want to next just go on to what I think is the most advanced motor in the world, which is our drive unit for motorsport. We currently power all the vehicles in the World Championship, Electric World Championship, with this unit, this drive unit. It's getting about 14.9 horsepower per kilogram. Just to put that in context, this carbon unit, apples for apples, about 3.9 horsepower per kilogram. And at the center of this, we have this incredible wave-wound stator, which is direct derivative of our production technology. And right in the center, we have this miniature rotor here. This rotor spins at up to 20,000 RPM, and this generates 469 horsepower. This is created in our labs in California. It's not built here. But this is, I believe, the most advanced in the world. And look what we've done, where everybody else puts carbon wrapping for motorsport, because carbon wrapping isn't a new idea. It's been used for a long, long time in motorsport where money is no object. Even in our motorsport application, we don't use carbon. And do you know why? Because I see motorsport as the proving ground to develop our technology into road cars. This is something that's been lost I remember D-type Jaguars using disc brakes at Le Mans in the 50s, but I don't know how much has happened since. This truly is a way we can advance our road car technology. So we don't want to put carbon wrapping even on our race technology, because I don't see that as a viable cost-down solution which is going to help save the planet at all. This has got to be in order to drive feasible solutions where all mankind can benefit, and that's what we're about. Okay. Now, moving on. Oh yes, I forgot to do the slides, 469 horsepower. Right, so the core thesis of why we exist and what we're doing here at Lucid is to push costs down of electric vehicles. And central to that is, what is the cost of range? A range of any car, whether you're making a car with 200 miles range, 250, 300, whatever. And it was always considered, well, that's just a function of how many cells you put in the car. Because it was felt that you couldn't do electric motor any better. It was inherently very efficient in the first place. And it's like range equals numbers of cells you can put in, or advancement in cell chemistry, which would advance energy density. And we really challenged that. Back in 2016, when we founded this company, we really hired some brilliant scientists and engineers, and we went on a crazy quest. Could we reinvent the electric motor? Could we invent the inverter? Could we take a holistic system, complete holistic view of this world? And you see, actually, the cost of endowing an EV, any EV, whether it's just 100 miles EV, with range, is what we're searching for. That is the holy grail, because we want to have a huge impact. Lucid's going to be huge. We're a small company at the moment. We're going to grow. We've got huge ambitions to have a meaningful impact upon the environment with meaningful volume. And this is our weapon. This is our weapon of making us differentiated, that we're able to make cars more cost effectively, because the cost of endowing any EV with range is the cost of the cells, dollar per kilowatt hour, divided by the efficiency, miles per kilowatt hour. And this is where this number, that's why I'm chasing 6 miles per kilowatt hour, to really push costs down. And already, you can believe it, we're already at 5, and our project, our mission 6, is already underway. Now, there's a misunderstanding here as well, because, some people question, well, why are you saving electricity? It only costs about 23 cents a kilowatt hour, and someone's buying a luxury car, they can afford it. Well, first of all, it does add up. But why are we doing this? It is true environmentalism. I think a lot of people will resonate that not all EVs are born equal. And I keep repeating this. Not all EVs are born equal. And this is central to that thesis. But I think that the cost of the energy is kind of missing the point. There is something much bigger, 550 times bigger. And this is a Bloomberg figure. They claim that pack level, battery level, is $128 per kilowatt hour. And so that's about 550 times the cost of the electricity. An analogy is how much, if a bucket of water, the water might cost you 5 cents, the bucket might cost you $15 to hold the water. It's that I'm chasing. And we're chasing not just 1 kilowatt hour, we can chase 20, 30, 40 kilowatt hours of energy. And that can have a profound impact and difference upon the cost of making a vehicle. I've exited the radiation zone there, so I can keep check of time. Excuse me. So, what does this mean now for a because this is key. We've shown that elements like the drive unit are really cost effective, but what profound impact does it have upon the battery? This is the key differentiator. So, we compared it with 2 competitors, an American market leader and a German luxury manufacturer. And we look at how far they go and how big their batteries are. And we've normalized that cost at the Bloomberg figure. I actually think it's higher than that, but let's accept Bloomberg's independent input. And that's how much those, if we normalize for Bloomberg rates, that's how much those cars' batteries are going to cost. So let's have a look if we actually normalized for the competitor range. How much, if they had Lucid Technologies, how much the pack would cost, okay? But there's something else. We've got to actually normalize for range as well, because these cars haven't got as much range. And that's when you see such a profound difference. This is Bloomberg figures. This is not some wild claim of mine. This is what the cost saving would be for the American market leader and the German luxury brand if they were to use Lucid's technologies that are in a current production car, Lucid Air Pure. The American brand would save $2,200. The German, more than double that. But there's something else, and I'd missed that until recently. You've got to allow for the reduction in mass as well. And if you allow for that at a standardized normal rate of about $6 per kilowatt hour, then the difference becomes much more significant. And we see this, and I've not shown anyone this before, this is the first time. This is the level of significance. And this is why, ladies and gentlemen, viewers from around the world, this is why Lucid is chasing efficiency. It's not just the environmental credentials. It's just not the impact upon people's pocket. It's not just the draw upon the grid. But it has a profound bearing upon Lucid's profitability in the future. We'll be able to make cars with less batteries, and this has the huge impact upon the cost. If for a family car, when we look at the bill of materials is the cost of all the things that go in to make the car. The battery pack can have an impact on that bill of materials of over 40%. There is no gasoline equivalent. So that brings me on to a relentless cost down activity. My colleague Gagendra is leading that as interim CFO. Eric Barth, my chief engineer, is driving BOM costs down relentlessly. Dr. Imad Dalala is working on more efficiency so we can have less batteries, and it's a relentless push right across. Stephen David, you're driving costs down here towards a lean manufacturing organization. And it's all about cost. And really, we're doing a holistic review of all the costs across our business model, because everything leads to one route. We need scale. And I'll cover that in a little while. But it's also about product choice. So I have made some comments recently which have been rather controversial, and I looked at, allow me to just digress into the world of pickups. I really think that it's very tough to make an electric pickup work today. Not one that's usable and cost effective. You know, we're talking about typical efficiency about 2.5 miles per kilowatt hour. Even with Lucid's technology, it's going to be really tough to push it more than 2.7, I tell you. And, you know, therefore, it's, you know, if you want a 300-mile range pickup, which isn't enough because if thing's got a tow, you're already into a pack size 120 kilowatt hours. Even with the Bloomberg figures, that's 15,000. It doesn't get sensible until, I think, the minimum threshold for a usable pickup is probably 150 kilowatt hours. And apart from the weight, because it reduces your payload carrying all those batteries, the consequence of that is, you know, you're going to have a pack which costs maybe 19,000, 20,000. And actually, I don't even think that 150 is enough. There are some pickups today with over 240 kilowatt hour battery size. Now, how on earth are you ever going to do that around $50,000, $55,000, $60,000 and make a business case? I mean, this is just back of the envelope, you know, a sanity check that I'm doing. And this is why I'm very reluctant I don't want Lucid to start thinking about a pickup. This is where we'd need to have a profound improvement in gravimetric energy density of cell chemistry as well as the work that we're doing in efficiency. Now, I said before I wanted to cover software, and it's crucial, and I really want to delve into this because, again, there's a huge misunderstanding here. And forgive me my rather crude mechanical engineer's view of software. Dr. Gaultier and JP is leading this now, but I see it as an iceberg. I see the weight of the iceberg. Underwater, you don't see. And unfortunately, what you do see is the tip of the iceberg, and that's user interface and graphics. And I'll say why I say that, unfortunately, in a moment. So, under the water, what have we got? We've got thermal control, anti-lock braking, zonal architecture, BMS, we've got charging, motor control. A lot of that, maybe not ADAS, but the rest of it, we're world-class at. How would we get 500 miles range? So most of what you see under the water, not all, but most, we're really world-class with in-house. Even our OTA broadcasts now we've brought it in-house as part of our in-house software stack. Let me just go through some of those features. In-house traction control, mentioned that before. That's why I showed Sapphire running with Grand Prix cars. They can run with a Formula One car. In-house motor control, truly state-of-the-art for the whole range of vehicles. We've even got a phenomenon known as in-house zero-voltage switching. This is when we're charging the car that the algorithms recognize when the voltage goes through zero in an AC form, that we stop switching. It's very subtle to reduce the hysteresis of that particular switch, just to save a few electrons. We're famous for our in-house battery management. That truly is race developed through 4 seasons of World Championship. And our in-house over-the-air software, let me tell you, not all OTA is the same, over-the-air. It's like not all EVs are equal. We've got a much broader and deeper OTA capability, reaching much more of the car than many. Just someone claims OTA, you need to understand what degree of OTA they've got. This is hugely significant for a software-defined vehicle, and that's what we've got. Another thing I'm really proud of is, and we've pioneered this has been over-the-air transmission of in-vehicle diagnostics. We had an example where a supplier made a faulty part, and we knew there were only about a few dozen of those faulty parts statistically out there. We had thousands of cars, and do we just have a recall for all those? That was a safety critical issue. And we looked in the laboratory. How would the lab identify a faulty part? And we found there was a signal if we gave an electrical impulse to this part. Good parts and faulty parts had a different output signal. So we coded this, and we transmitted this over the air. And each car conducted its own personal health check. And the cars which did have the faulty part signaled back to base, and we were able to bring those about 30 or 40 cars that were affected, a minimal percentage. And because of that, we were able to get those ones that did need the fix back really quickly. I think this is the future, and we pioneered this with NHTSA. I believe we're the first to create such pioneering technology. I think it's really exciting. We also have in-house testing automation. This is, advances our own development process. Now, when I get onto the core of the software, what do people see as software? They see it as the interface, the human interface. They see the tip of the iceberg. And this is where I'm disappointed in ourselves. We can do better. We've got the best car in the world. We're not known for our user interface, and it should be better. So, there's a mea culpa here. I've made sweeping changes to our software organization. I've installed new management people that I've worked with for many years, personally taken charge of this. And we've got a really aggressive schedule of a roadmap of tons of things that we're going to implement through the over-the-air to get truly world-class user infotainment and user interface, including ADAS features. And so talk is cheap. I don't want to just tell you what we're going to do, because there was a reason we broadcast a major update 2.4.0 just over the weekend and yesterday, because I wanted to show this isn't just stuff we're going to do, it's already started. And this has been super well received. A whole bunch of new features. Our owners in the room hope you're experiencing it. I see some nods. I hope you like this. And I'm personally driving this. This is going to change the perception of Lucid. We truly are a tech company, but just our user interface is not as good as it should be, and it's going to be world-class. Right, JP? Yes, he said yes. The man said yes. And holy crap, they like it. They like it out there. So you can read the accolades. So that is our Achilles heel right now, and you don't see the true technology under the iceberg. That tip of the iceberg, we're going to just completely transform over the next 3 months, 6 months, 8 months, 10 months, and so on. Now, I want to get onto some real meat here, because today is about Lucid Gravity, best SUV ever. And we've got a whole bunch of features here. 440 miles range we're still shooting for. We've got an incredible, disparate array of features that no one's ever seen before. Handles like a sports car, blow away an Italian supercar. It's got the practicality and space. It's got the roominess. And July 24, we put the first car down the line. We're building pre-production. It was a great honor, actually, with all my dear associates here. And you're going to see this plant right now, very soon, to drive the first one off the line, that black one. And you're going to go out for rides in Gravity. Now, for those who've been following Gravity, we have this series of videos out on the website. Please follow, tune in, The Road to Gravity. What makes it so awesome? And I think actually, this is going to make an incredible compendium of how a vehicle in a factory is readied. And we're showing far more transparency than I think any other car company in the world would do. So what makes Gravity so good, and how can you believe it? Well, look at Air. With Air, look at Air compared, the people package compared with the competition. This is compared with the market leader, American car, and the key German competition. Look how much more interior space there is in an Air, and it's no bigger on the outside. This is about creating more space on the inside than the outside. We're creating a TARDIS for those Doctor Who fans. And so we're using that with Gravity, and we're going to take it to the next level. I want to be clear about this. Gravity is revolutionary packaging. No one's come close to this. It is, I use the word hesitantly, it's truly revolutionary. And we look here at the 3-row seating configurations. My colleague Nick Twark is 6'5", and he fits in the rear in the 3rd row. Zach, you're 6'6", you fit in the rear in the 3rd row. I rattle around in there. So this is comparing the people package, the occupant package, with some key competitors. And I really, shaded in grey is Lucid Gravity. And we're comparing it with some German competitors, but the red is a full-size, long wheelbase, big American, complete, full-on SUV. And we got more roof on the inside by about an inch than that full-on, full-size SUV. So let's and how can we do it? Because of this miniaturization of the drive units, and even more significantly, that allows for less batteries. So where there's less batteries, there's more room. And look at right at the rear, look at the space for the third row, nice and flat, because we've moved the hump of the battery pack from air forward to gravity for that very reason. And still get around 440 miles range. Let's compare the exterior size. So there's your huge American long wheelbase SUV in red, and Gravity's there in black. And there's more room for the people in the black car than the red. And this is transformative. Let's look at the cargo space. I've chosen a German competitor here, and this is the difference. You see, the German competitor has this space here, and what we've got is this orangey brown space. It really is. I mean, it's probably close to double the space, and we got a completely flat loading area, about 6'10". You can sleep in the back of this vehicle. Just amazing. So there it is, Lucid Gravity in all its glory. Best EV ever. You're going to see it being the pre-production cars down the line very soon. You're going to have a ride in one, and you're going to witness it. And we've also got some competitor vehicles out there, because otherwise you don't see the difference. So let's have a look at it. We've also got this frunking facility. When we look into the rear, we see how the rear seats tuck down into the rear space sequentially, leaving a completely flat area here. And the second row is still up. Then we can fold, put covers on, fold the second row right down here, and it fits a surfboard, bikes, and also we've got great infotainment in the rear, an incredible lifestyle vehicle, and just super useful features like these shelves for docking a laptop, for example. A great car for all the family, and incredible connectivity and software as well. We're also proud to announce that we're going full on with the NACS charging standard, which will be integrated into vehicles in early 25. There it is. So we'll have access to the full 15,000 supercharge network. This is the incredibly safe vehicle as well. And if I can trigger this crash video, maybe it's another strike. Here it goes. So we have extensively crash tested this vehicle. And if you look at take a look later, because this will be on our website, just how close the computer simulations are to the actual events. That's what I'm really pleased at. That's what is a specialist subject of mine, is crash performance. See how these crumple zones crumple in these system tests and make this car extraordinarily safe. This is an absolute passion of mine, and it cannot be compromised. Now that one is brutal. That shows the narrow offset, and that wheel is designed to rip away. I used to play rugby, and when you get an incoming tackle, you push the tackler away, and that's what that wheel does. It pushes the rugby player, in this case, another car coming at you, just like a rugby player, pushes that player away. And it's designed to rip off in an extreme situation. And then really to cap all this off, we have next generation Lucid Gravity user interface with a squircle steering wheel, 5G, 34-inch OLED continuous screen with a whole sanctuary mode of features. And actually what you're seeing with Air is the cascade of some of that tech coming into Air, and we're going to have a synergy between the two, which is going to be super cost effective. Now, we've got the best lighting technology in the world. We're known for the most homogeneous lights in the world. And here is some of our lighting technology, which you may like to have a look at in due course. Developed in-house, over 9,000 micro lenses, the most homogeneous and complete lighting array in the world today. So that team now, in-house team, in-house lighting technology, after making the most advanced lighting, which is on Lucid Air and Gravity, we're making our in-house augmented reality heads-up display. That's done in-house. I don't know anybody does that in-house. And why are we doing it in-house? This is a significant step up from anything I'm aware of in the market today. It is going to be off the scale awesome, and that's coming. I'm super excited. I don't like HUDs. They're always disappointing. Heads-up display, that is a HUD. This is next level, and you can see some of the, from the graphics, some of the overlay of the virtual with the reality. This augmented reality is just amazing, in-house. And I mentioned also we're going to make the whole user interface compatible with Air, Gravity, and midsize. And there's going to be a synergy with this and a cost effectiveness that we'll have one team designing and developing for a whole range. And this is about the scaling effect and the cost effectiveness of that scaling. So, ladies and gentlemen, I present to you Gravity. Now we move on to the factory. Before you go around the factory, let me show you what you're going to see. And back in 2020, we made the very first purpose-built factory here at this very location. But it was relatively modest. We had a body shop there to make the bodies of Lucid Air in the foreground, and the big building in the background was destined to be our paint shop. But to reduce costs and be really lean, we actually manufactured the assembly downstairs and kept paint upstairs. So now everything's changed. Look at what we've got today. We've expanded, I think, nearly 3 million, I think it's 2.85 million square feet. What we've got here is the stamping facility, in-house stamping. It's going to be awesome. We've got, this is the body shop for Gravity, and we've expanded right down there for a state-of-the-art powertrain logistics and general assembly, and now this is dedicated to world-class paint. So let's look at that, and it's about cost down, cost down, cost down. We've vertically integrated stamping. We've been investing a fortune in this in the last year. That's been shown on our accounts. But we've also been spending far too much money on trucks bringing stampings in, and the scrap that's associated with that. There's significant cost savings. We don't have to pay for this investment anymore. We won't have to pay for trucks. We will have far less scrap, and we're going to have significant cost savings, Stephen, with a much more integrated operation and much more quality control as well. So you're going to see all that. It's going to be awesome. Then we've built this new automated body facility, and I learned yesterday it's not 247 robots. Another one snuck in the door. It's now 248. Well, I don't know which sneaky robot it was, but anyway, we got 248. This is all aluminum construction, similar to an aircraft. And a lot of cars are spot welded steel. This is aluminum. And we've got some really interesting technologies which I'm going to take you through before your tour: castings, extrusions, stampings, and hot formed age-hardening alloy stampings as well for structurally significant zones. This is state-of-the-art, super automated, with advanced vision systems to really control the quality and the dimensions. This is a laser-based, high-tech quality control. Then we move to state-of-the-art paint shop. Now let me tell you, there's kind of two sorts of paint shops. There's ones which have got great paint and they're bad for the environment, or there's water-based paint shops and the quality sucks. What we've got is, I mean, I can't believe it myself. The team have developed some wonderful processes, and we've got true, it's like a Steinway gloss piano black look, and we've done that in a truly sustainable way. This is technology at work, exceptional quality, and now we have the scale. In that facility, we've got the opportunity to bring costs down. Another big area of cost for us was shipping truckloads of supplies in from a remote logistics center. We brought that in-house. You'll be able to see that today. That's just about 100 yards from the line. So we'll have a lot less OPEX here. We're going to go lean we can reduce our inventory because of the close proximity, and that will mean less working capital. And I think that's very important for the business, having that all under one roof. But it's been a huge investment to get this. So what you're seeing is how our finances are dominated by long-term investments for the future. This is a long-term play, and we're absolutely committed to this. It's scale that will give us a profitability. And then in general assembly, we have a flexible manufacturing line, and this is significant. This one line takes air and gravity down it, and we designed the line originally a few years ago ready for gravity, and you'll actually see the gravities coming down the line there. They're literally being built on the line. These are real pictures, and there's me driving the first one off the line just about 4 weeks ago. These are the pre-production cars. And then you're going to see the crown jewel, the state-of-the-art powertrain facility. This is where we make all the amazing stuff. Now, I'm not showing you everything on this picture because some of it's top secret. Sorry, viewers at home, and sorry, competitors who might like to see. But our esteemed guests, without cameras, you're very welcome, and we're going to actually show you some of the inner secrets from our inner sanctum, really the crown jewel. This is, I believe, the most advanced powertrain plant in the world. We've got a lot more automation. For example, the Wonderbox is now pretty highly automated. A lot of the battery manufacture, the motor is highly automated. It's that degree of automation. We're putting 3 lines in parallel to get the scale, to get the economy of scale. And this is a huge investment for the future. And it's really right in the center of this building, top secret area for good reason. I think it's the most advanced, most integrated powertrain facility. So, to wrap up, you're going to see all that, but I just want to bring back to Lucid Air this sheer bandwidth of lead in performance that it's got, the most range, fastest charging, most aerodynamic. It's got the best space, best 0 to 60, best standing quarter. It's the most powerful mass-produced car ever, the most efficient. I mean, I don't know in 130 years of automotive history whether any one product has managed to grab such a diverse range and disparate range of attributes. So Gravity, you can believe me, it's a brand new SUV platform. It's truly revolutionary in its packaging. 3 rows and 7 seats. Exceptional interior space. It's got unprecedented practicality. It's got dynamic handling. It's got 440 miles of range. We're going to have NACS charging, which will allow 200 miles in just 15 minutes. And we're going to have a towing capacity up to 6,000 pounds. Gravity truly is the best SUV ever it is set to be. Make no mistake. So before you go off on your tour, I just want to cover the plan for the future of the company and where we're heading. We need scale, scale, scale. It's all about economy of scale. Our finances are dominated by scale. They're dominated by long-term investments for the future. We've got to grow Lucid Air sales. So how are we doing with that? Well, we came off a record in Q1 this year, another record in Q2, and I'm delighted to say that through August 31st this year, we surpassed deliveries for all of 23. And furthermore, I'm really pleased with the way things are going in September. I think that's great. And hats off to the whole team. And we've never been manufacturing constrained, maybe right in the very beginning. We've been market constrained. We can make them. And as the word gets out just how awesome the car is, we've got the ability to ramp up production. But we've been prudently managing our production numbers with sales demand because we don't want to build up an inventory, and we want to be very careful with our cash. So next thing we've got to do, get Gravity into production. We're really close. Gravity is scheduled for start of production late this year, and we will be taking orders at a moment in the future. And we've not announced anything yet because I think all this taking premature reservations ill serves the customer. I think that we need to announce, and we will do in the near future, when we're going to take orders for Gravity and precisely when that start of production date is going to be. But this event today is not about that. This event today is to show that Gravity is the best SUV, that it can only be possible with our tech, and to show you the manufacturing of that tech, to prove that it's affordable to make and eminently makeable. And The third thing then we've got to do is get bigger scale, manufacturing scale mid-size, 30 times the total addressable market of Air. And to that aim, we're making great progress in another factory with our dear friends in Saudi Arabia. This is our AMP2 facility, scheduled for 150,000 units per year. We're putting the steel up right now. So this is another part of our big investment. So we invested in Gravity. We're investing, there's a whole team working on mid-size. We're working on 2 factories. We're building a new powertrain with Atlas for mid-size. And these are our outgoing costs at the moment. And then finally, what we've got to do is to license and sell our technology. And those are the 4 steps to scale and having meaningful impact and execution, the vision that we had when we started this company way back in 2016 with a vision to make cars go further with less and make them more affordable. And I don't know if I should show this last photograph. Am I allowed, Maynard? He says no. I'm going to do it. I'm going to do it anyway. Right. There's a devil in me. I'm going to do it. Should I do it? Oh, yes. I got a vote at home. Okay. So this is just a sneak peek and a glimpse of mid-size. There it is. I hope you like it. Thank you. Well, we'll have a proper event, maybe sometime next year. And so really, I want to welcome you all to the tour of the factory, and I hope you really enjoy your day. We're going to have a blast, and I'm glad you didn't go too heavy on breakfast, because some of you will be going out with me in the Sapphire very soon. Thank you.
So I am the last person between you and the rest of a very great day. I just want to go over a few things. Can we put up the other? Oh. And let's close.
The new Lucid Gravity SUV could be one of the most important electric vehicles introduced in years. This thing promises huge range, incredible acceleration, vast amounts of interior space, and it should have more amenities than a 5-star resort.
Can we just start with how epic this looks? I mean, this is the right car at the right time.
Gravity is the electric, go anywhere, do anything vehicle.
Sometimes it feels like it's handling like a hot hatch or a sports sedan, but it has all the practicality and all the utility of an SUV.
We have this beautiful exterior body that's got great aerodynamics, great engineering, and then when you sit in the interior, it's got this wonderful, huge space and the connection to the California landscapes.
We have the best electric technology, and our vision for an optimized vehicle is built around taking maximum advantage of that technology. So you get something that's efficient, you get something that's fast, you get optimal space and utility. That's our secret sauce.
There's some people who say you need the car to be super logical. That is a wagon, that is an SUV. Oh, there's my sedan. But when it can be everything and we break the paradigm of what is a car, what is this SUV, and it can be all these things, that's what we want. So that a customer gets in the car and is delighted.
I would love that this car is seen as a game changer. It's a new standard for what an electric SUV needs to be.